A router is a network device that transmits packages between different networks or LANs. Routers are needed to reach hosts and devices that are not part of the same network. They use a routing table to browse the networks. On the left, we have network 192.168.10 with a mask in /24. Addresses range from 192.168.10 to 1.255. On the right, we have the network 192.168.20. As it is the same mask, addresses range from 192.168.20 to 2.255. As it is not the same network, if the machines on the left want to communicate with the one on the right, you have to include a router in order to direct the packets. Switches allow you to communicate in a single network, and routers allow communication between these networks through the interfaces connected on each of them. They use routing tables to route traffic between different networks. On this new topology, which has just been displayed, the LAN-A switch switches its data between PC 10, 11, and 12 links. The left switch communicates only on the network 192.168.10. The LAN-B communicates only with the PCs 20, 21, and 22, which belong to the network 192.168.20. A PC that is part of LAN-A cannot communicate with an LAN-B PC without the help of a router. They are the ones that allow communication between hosts that are not in the same network. A router can have different interfaces connected to different networks, and that's how it can get traffic from one network to another. Cisco offers many different routers, which have many different shapes and sizes. Here we represented a Cisco router ASR 1001. Although there are different models with different features, the main function of a router is to route the packages. Components of a router include the motherboard. It is the central map, which contains the critical components of the system. It provides connections to other devices and interfaces. We've got the processor. This is the chip that is installed on the motherboard and performs the instructions. And we have memories. There are 4 main types of memory. We're at RAM, which stores the data while the processor is working. Type of volatile memory, that is, its information is lost when the power is removed. That's where the running-config is stored. On the go at NVRAM, which retains its contents when the router is off. This is where the startup-config is stored. It also contains the software configuration register, which is used to complete the image to be used when moving the router. We're at the ROM, which is a dead memory of the motherboard. Its contents are not lost when the power is cut off. The data stored in the ROM cannot be changed. It can provide a user interface when the router cannot find the startup-config file. And it contains startup software that helps the router get started when it can't find a valid iOS image. And we have flash memory, which is a non-volatile storage and can be erased and reprogrammed. This is where the image of the Cisco iOS software is stored. On this representation of the Cisco ASR 1001 router, you can see the different types of ports. Management ports, which are intended to connect a terminal to administer the router. For example, the console port can be used to connect a PC to it and have it entered into the Cisco iOS. High-end routers can also have an Ethernet port that can only be used for remote administration to be able to connect to it from another subnetwork. To be used, this port will need to have a configured IP address. As for the router's auxiliary interface, it is used for remote management, for example by connecting a modem. And we have the network ports. The router has many network ports, such as LAN or WAN ports, which accommodate either copper cables or fiber optics. An IP address must be assigned to each of these ports in service.